quick recap. Okay, so I'm going to do 2-minute recap about stoic. So what is stoic? Stoic is the relationship between something that you have versus something you want more information about, right? So when we talked about cupcakes last class, we were like, it normally takes 3 eggs to make 12 cupcakes. And then the question was, hey, we have 6 eggs. How many cupcakes could we make? So you have double the amount of eggs, you can make double the amount of cupcakes. That's basically stoichiometry, right? So you do it in cooking, we do it in chemistry. So here we go. This question asks, what is a mole ratio for the mole bridge for the conversion of carbon dioxide to iron 3 oxide in the following reaction? So things to like keep in mind. When you cook, you use a recipe. In chemistry, we call it a reaction. So it's exactly the same thing. So I use those words interchangeably, just so you know that it is not a scary word. It's the same thing. Another thing to keep in mind, another reminder, is that in chemistry, we don't like to use cups and teaspoons, ounces. We don't like any of that. It's too complicated. So like when you see and like look up a recipe, for example, look at this. You have cups, you have like pieces of eggs, right? It's like too much. There's like too much stuff. Like when you normally cook, there's like put like 3 pinches of this and like 4 tablespoons of that. And then chemists were like, that's confusing. So they decided, let's not do any of that. We're gonna make all of our recipes always in moles. Always. Which is why they don't write it, because it's always in moles. Nobody likes teaspoons and tablespoons, or teaspoons, tablespoons, cups. Everything's in moles. All right, so now when you're doing a conversion like this, you got to think about, what do you have? What are you interested in? So it says I have carbon dioxide. So this, I'm going to highlight here. This is what I have, right? And then this is what I want. I want more information. Whoa, you can't see that. I want this, right? So when you're doing a fraction, right, of information, you got to think, okay, what do I want? What do I have? Has to go in a fraction. What you have always goes on the bottom. What you want always goes up top. So like your unknown, what you're looking for is always on top of the fraction, right? Because that's what you're interested in. So when you look at this recipe or this reaction, you got to sort of ignore the things you don't really care about. Like the question sort of eliminates like some of the choices here for you. The 2 things we're interested in, once again, is carbon dioxide and iron oxide. That's these 2 things right here. So what do we not care about in this particular question? We don't care about carbon and we don't care about iron. So when you look at the question, this is question number 2. So if you hop over to question number 2 here, you can already eliminate half of your answers, right? Remember this, what color did I make this? This is this, right? And this is this. So what 2 things do we not care about? We don't care about carbon, we don't care about iron. So when you're eliminating answers, you can get rid of the carbon and iron. So we don't care about them. They're important in the recipe, we just don't care about them in this question. Okay, then what are you left with? You're left with 2 choices here. The thing is, you got to determine what you want, what you have. So we already labeled it up here. What we have is carbon dioxide. What we want is iron oxide, right? Like this. This setup, there's only one choice. So what is the answer? What has iron oxide on top and carbon dioxide on bottom? Boop. So you know that this is the answer, okay? Now, some of you might ask, well, where did the numbers come from? Well, remember, the numbers just come from the recipe, the reaction. So this number right here 2, right? Remember, instead of 2 cups, for us in chemistry, we write 2 moles. Right here, this 3, instead of 3 teaspoons, chemists always use moles. So that's where these numbers come from. So we know that the answer to number 2 then is the last one right here. Any questions so far? Okay, so then you're gonna have to move the Pear Deck on your own if you're. So now we're gonna go to question number 6. Question number 6 looks scary because everything's blank, okay? But it's just review of what we learned last class. So I'm gonna go pretty quickly on this one. Once again, recall, so I like writing this every single time. The recipe, the recipe and reaction is this right here. It's the same exact recipe that we've been dealing with. Remember that every recipe is always measured in moles. So these are just reminders for those of you just following along. This particular question asks, what is the number of moles of iron produced when 5 moles of carbon react? So it sounds scary, but remember, just like the eggs and cupcakes questions, it's the same concept. Instead of eggs and cupcakes, it's asking about carbon and iron. Okay, so things to just label real quick. This is the thing that's given to me in the problem, right? This is what I have. This is the number that you're starting with. What did you start with? What was given to you in the problem? What number is it? It's 5. That should be like the easiest number to put down here. What does it say? Moles of carbon. So you know moles of carbon is what you're starting with. This is what we start with. Boom. Very good. Thank you, Edwin. Then you want to think about what you want. This is what you want. I want moles of iron. If this is what you want, then where does it go in your fraction? On top. So moles of iron has to be on top, right? Actually, let me, sorry, I'm just going to color code this real quick. Moles of iron is what I want, right? So if I were to highlight this, that's this right here. Then what do I have? The information that I have is what? Moles of carbon. So that has to go on bottom because this is what I have, right? So in the recipe, that's this right here. What you have goes on bottom because you're trying to get rid of it. What you want goes on top. That's your goal. So what are the numbers that you're going to put in this fraction, right? What does the recipe, the reaction tell us is the relationship between iron and carbon? The relationship between iron and carbon is 3 and 4. Make sure you put the right number with the right substance, right? So 4 goes on top, 3 goes on bottom. Remember, this is what we want, right? Your answer has to be what you want. I want what? Moles of iron. So that's got to be your end goal here. Can somebody calculate for me what you get when you calculate this stuff? Just so that I think I'm not crazy. Yes, thank you very much, Garrett. Can someone calculate this answer and like drop it in the chat just so that I can verify that I calculated it correctly as well? Just anybody. All right, thank you, Edwin. Let's see. So you did 5 times the top number, you divide by the bottom number, right? Hey! All right, so 6.67. So you're going to drop that here, right? So 6.67. Perfect. You're going to take this and put it where? In question number 6. So let's drop it in question number 6. So let's hit up question number 6. So this is what we started with. I usually make this yellow. So 5 moles of carbon. So this is more like a reading test. What you want goes on top. So what I want is moles of iron, which it was here, right? Make sure I get all my coloring correct. And then what do I not want? Moles of carbon. This is the bottom. And then the answer we got was 6.67, which is on here. Perfect. What do we want? Moles of iron. So make sure that on number 6, you actually put every single thing correctly. You filled in every single drop-down box. So I'll give you a second to catch up, and then we're going to hop to question number 7. Although I think Miss Bailey's class did not do number 4. Did y'all do number 4?
No.
Okay, I'll quickly do number 4 and then we'll hop to number 7 because I think my class already did number 4. All right, does anybody need more time on number 6 or are we good to go? All right, let me do number 4 really quick. This is a really simple one, so y'all should be able to answer this quickly. But I did this with my class last time, but let me just jump onto this. This is a cupcake question, so pretty easy. The question is, if you want to make 36 cupcakes, how many cups of water do you need? So you're sort of working backwards. You know that the relationship between cupcakes and water is for every 12 cupcakes, I need 1 cup of water. So you know that relationship. This is the information I'm starting with, so I'm going to write 36 here. The relationship between water and cupcakes is for every 1 cup, I can make 12 cupcakes. So what is the answer to this particular problem? How much cups of water do I need? Very good. So if you did the math really quick, you would get 36 times 1 divided by 12 is 3. Does everybody understand why it's 3? Does anybody have a question? I did this one pretty quick because you did most of it already last class. Okay. If we're good, everyone got number 4. Then we're going to hop to number 7. So number 7, so you're going to have to change the slide on your own. Here's number 7. So I'm going to do it in the Pear Deck, and I like to transfer my answers later. So this one sort of jazzes up the problem. So now let's take a peek. This particular one has the same exact recipe or reaction, right? Once again, as a friendly reminder, all our recipes are always in moles. This particular question says, how many moles of carbon dioxide, so this is what we want, will be formed when you have 15 grams of iron oxide? So this is what we have. So if I were to just like color code it here really quick, then the 2 things I'm curious or interested in is this one and this one. So temporarily, right, we don't really care about this or this, okay? So we can just ignore it for now. People tend, right, to like draw an arrow of interest here. So I have this, but I want this. So people draw arrow like this. You always point to your unknown. This is what you want. Your want is your unknown. Now, here's the problem. Your recipe is all in moles, but the problem gave you what? Whoops. Gave you grams. And you're like, wait a second. That doesn't match. So for example, going back to your cupcake question right here. If I gave you, instead of cups of water, I gave you gallons of water. And I said, hey, here's half a gallon of water. How much cupcakes can you make? And you're like, wait a second. My recipe is in cups, but you gave me gallons. Then what do you think you have to do in order to follow the recipe? You have to, I hope you're thinking it in your head. You have to convert gallons to cups because gallons is not in your recipe. Cups is in your recipe, right? Does everybody understand that? So when you look at this particular problem, you're like, okay, I have grams, but my recipe is in moles. Problem, so I need to convert it to moles and then I get to use the recipe. So right now, your biggest problem is that right now you're stuck in moles. So right here, this is the number given to you in the problem. You were given grams, 15 of them. So you're like, okay, I'm going to convert it. When you see grams, so you put it on the bottom because you want information about moles. You want to convert it to moles so that I can use my recipe. I can use the reaction. This is where people mess up, like really commonly, is right here. When you see grams in a fraction, who remembers this from many weeks ago? Like 4 weeks ago, we talked about this. When you see grams in a fraction, where do you get this information from? Who remembers? Every time you see G, grams in a fraction, like a conversion fraction, where do you think you get this number from? Get it from somewhere. Edwin, here's a heart for you. You get it from the periodic table. Oh, Jada, Caroline, I love you. Right, you get it from the periodic table. Very good, which is why I conveniently, on the next slide, put a periodic table so you can calculate the mass of this compound, okay? So anytime you see grams right here, you gotta look on the I'm gonna type it because I cannot write that small. You're gonna have to use the periodic table to find this grams number. So if you look at this compound, it's 2 irons, 3 oxygens, 2 irons and 3 oxygens like this. So when you look up the periodic table, you have 2 irons, 3 oxygens that you got to add up together. Okay, so I am going to do that on my calculator. Whip this out real quick. Times 2, because I have 2 irons. I have what? 3 oxygens. Whoa, that is not 3 oxygens. 3 oxygens, and then add it up together. So the mass of this compound weighs 159.7 grams. And that is the number that you're going to put right here. This particular number came from the periodic table. Does everybody understand how I got 159.7? Okay. Okay. So here we go. Sorry, I closed the window so I can't find y'all. Okay, now this is this is where people mess up. Is this number right here is the most common mistake. This number right here. Here's a question I want to ask you, and I'm going to ask it several times. How many of these compounds right here, this Fe2O3, weigh 159.7 grams? How many of iron oxides weigh 159.7 grams? Like how many compounds do we add up together to get 159.7? Oh, not 15. So I'm saying like how many iron oxides weigh 159.7? Yes, I think Jada was right the first time. It is 1. Okay, so what am I saying here? I know it's confusing, so think. What I'm saying is 1 iron oxides weigh 159.7 grams. Okay, 1 of these compounds weigh 159.7. Did we take the mass of 2 of these compounds? No. Did we take the mass of 3 of these compounds? No. It was just 1. We took 1 of these, added them up to get 159.7. The biggest mistake here is people want to put this number right here, a 2, but that is not what the fraction is saying. Only 1 compound weighs that much. You cannot look at the recipe until you're already in moles, but we're not in moles yet, which is why you're not looking at the recipe yet. Once you put a 1 here, so 1 of these weighs this much. Now at this point right here, you can now look at the recipe. Now that you converted it to moles, so like earlier, my example was like we're in gallons. Now that I convert from gallons to cups, now I get to look at the recipe and then follow what it says. So right here, moles of carbon, and then over here, moles of iron oxide. So what numbers are we going to put at top and bottom? What does our recipe, our reaction say is the relationship between those two things, right, from the information above? So we look over here. We're going to use this number. We're going to use this number. And you got to make sure, right, that you're following, right? You're matching. So you get these numbers from your recipe or your reaction. So what number goes on top and bottom? So matching my green number and my blue number, like this. Does anybody have a question about where I got these numbers from? If not, I'm going to ask you to then somebody calculate for me what answer you get so that I can make sure that we agree on the answer. So we started with 15. Did someone tell me what answer they get just so that I can double check? If we can agree on the same answer. So remember, you start with the number 15, you're going to multiply by 1, you divide by the bottom number, you multiply by 3, you divide by 2. Does anybody get an answer? I know it's tough because you have to typey. All right. While somebody's calculating that, I'm going to go ahead and transfer all these numbers here to the actual daily check. All right, thank you, Garrett. Let's see if we got the same answer. Yes, perfect, very good. All right, so then I'm gonna go ahead and copy down everything that we put on here. I'll go ahead and write down the answer. It is 0.14. I believe we got the same exact answer, but let's transfer it all over here. This was 1, this was 159.7. This came from here. This came from here. So 3, 2, and the answer was 0.14. Perfect. Okay, so like I said, most common mistake is this part right here, is that a lot of people here want to put 2, but do you see how you can't have a 2 here and a 2 here? And this doesn't make sense. 2 iron oxides does not weigh 159.7. Only one of them do. So please be careful about this. I'm going to leave here for a second for everyone to catch up. Make sure you filled out number 7. The last one is number 8. Number 8 looks just like number 7. So if you're like, I'm super confident, then jump into number 8. See if you can do it on your own. Otherwise, you can follow along with me. Anybody need more time? All right. For those of you who are confident, you can go ahead of me. For those of you who want to follow along with me, we're going to jump to number 8. This is slide number 6, by the way, if you're on my Pear Deck. All right, this one has a completely different recipe, completely different reaction. So the recipe and reaction are here. Okay, I like to make some notes to self. Remember, every recipe is always measured in moles. I'm going to label some stuff. So here we go. How many moles of nitrogen? So this is what I want. Well, actually, let me color code it. This is what I want. Will be formed when 38 grams of sodium nitride reacts completely. This is what I have. Because this is the information that I am starting with, right? That's why this number is right here. This is the number given to me in the problem. Remember that your recipe, Remember that your recipe is in moles, but you are given grams. So you're like, same problem as number 7. Is the exact same problem. So you're like, okay, in order to use the recipe, I need to convert to moles. So you're going to do the same thing. I see this grams in a fraction means I have to use the periodic table. Then you're like, okay, how many of these compounds am I adding up? Just one. One of these compounds weighs this much. Can somebody tell me how much this compound weighs by any chance? So once again, you can hop over to your periodic table. 3 sodiums and 1 nitrogen. So sodium is over here. So you have 3 of those. And you have 1 nitrogen over here. Whoops. 1 nitrogen over here, so 1 of those. Does anybody have the mass of this compound by any chance? 3 sodiums. 1 nitrogen. Well, I hope it's 82.98. If I'm wrong, you can let me know. Oh, is that your final answer? I don't know what the answer is actually, Edwin, so give me a second. So I'm going to go back and, okay, someone can confirm with Edwin there if you agree with his answer. So I'm going to drop 82.98 here. Now, this is the important part right here is now I get to use the recipe. So now I'm going to follow, right? This is this. This is this. So I'm going to use the appropriate numbers here. So this is a little tricky here because you're like, wait, there's not a number in front of N2. So if there's not a number, what number do you always assume? Because it's secretly there. Very good. A 1. All right, perfect. So now we're going to drop this into our calculator. Edwin already got an answer, so I'm going to go ahead and like type this in to see if we agree. I never trust my math. I am horrible at typing. So times the top, divide by the bottom. So multiply the top, divide by the bottom. Yes, very good. You can put 0.22. It will count it right. If you technically round, it becomes 0.23, but either way, it gets you to the same answer. So it will count it correct, and no stress about rounding. So if you put 22, it'll be right, no stress. So this is how the final answer looks like, okay? Does anybody have a question? I'm gonna transfer the answers to number 8. When you submit your assignment, you should be getting 100 because we did every single question together. So let me drop these numbers in. Whoops. Yeah, who got 100? 100. 100 on your daily check. 100 on your daily check. So what, this is 1, this was 2, and then the answer is what? Yes. I'm going to leave this here just for a second while you make sure that y'all got it all down. All right, so just really quick. Yeah, 0.22 will be counted correct as well. So last thing, I'm going to leave it here for a second, but last thing for the rest of y'all, right? Your goal is you have to finish Ed Puzzle Part 1. So if it's not done, you gotta finish it, okay? Next class, okay, you're gonna watch Part 2. But if you wanna like get things done early, then finish Part 2 as well. So